All right, so 12.5 is about scatter plots and lines of fit. So a scatter plot is a graph that shows the relationship between two data sets. So if we look at this one right here, we are looking at the restaurants, sandwiches, and we are trying to figure out what are their calories compared to the grams of fat. So the way that you would read this is you would look at a point. So let's look at this point right here, since it's on a grid for us. Okay, and it has 30 grams of fat and is 60 calories. So I look at the X for the fat and the Y for the calories. Okay, we could also predict, like, what if we had a sandwich that had 40 grams of fat? Then it would probably be somewhere right around here. Not necessarily sure where, but we could say, oh, maybe it has 700 calories. So we can make a prediction based off of the trend. Okay. But if you know one piece, then you can figure out the other. So if I told you that there was a sandwich that was 475 calories, so let's just estimate here, then that sandwich has about, 12 grams of fat. Okay. Within these, there are 3 different types of relationships that a scatter plot can have. So just like the slopes of a line, it can have a positive relationship where it's going up overall. It can have a negative relationship where it's going down overall. And then no relationship, it kind of just looks like a blob. There's not really a trend one way or the other. Now, the closer the points are together, the stronger. So strong relationships have points in a clear trend. And the weaker it is, the points don't, or they have a trend, but the trend is not as clear. So we'll say the trend is not as clear. And what we use to define the strength and the weakness of it is this thing called a correlation coefficient. So how well are they correlated? So the stronger ones are at the end, where the points are closer together. So a negative means that I have a negative relationship, and a positive means I have a positive relationship. So if we were to draw a little scatter plot for this one, then they'd all be in a straight line going down, and for this one they would all be in a straight line with a positive slope. When that's 0, then they are all over the place. Now let's say, what if it's in the middle? So this would be 0.5. It's positive, but it's not really that strong. So I've got points kind of going up, but they're really spaced out. Or let's look at maybe negative 0.7. So that would be, they're going down, and they're like pretty obvious that they're going down, and they're relatively close together. So we use this range between -1 to represent negative, all the way to 0, to +1 for the slopes that are positive. Okay, so of these, which one has a relationship? Okay, well, this one has a positive relationship. It's not super strong, but you can definitely see that it's a positive trend. This one on B means that there's no relationship. They're all over the place. So when something has a positive relationship, it means that as television size increases, the price also increases. They're both going up. Whereas when there's no trend, you can say that the person's age is not related to the number of pets they own. And mostly what that means is if I know someone's age, then maybe I could tell you how many pets they had if it was predictable, but it's not. There's no relationship between the two. Okay, so if we look at this data, they're telling us that in the first week we sold 19, second was 15. If I plot points for these, first week I sold 19, and then second week I sold 15, and then third week was 13, and then 11, and then 10, and then 8, and then 7, and then 5. Okay, so we have 8 data points. This is a pretty strong negative trend. They're relatively close together. They're almost in a straight line, but not quite. And what we're going to do now is see if we can draw what's called a line of best fit. You'll also hear it called a linear regression. We usually use a calculator for linear regression and for line of best fit. So we're going to try to draw a line that goes through, not necessarily through the points, but we want to have the same number above as we do below the points. So if I do it right there, let's actually shift it down. Okay, so I have 3 points below the line, and then I have 3 points above the line and 2 points on the line. So this is going to be a good fit because I have about the same number above as I do below. So we want same number above as below. All right, so now last but not least, we want to come up with an equation for this line. So we have y equals mx plus b. So if I look at the slope, I'm going to use the 2 yellow points because they are actually on the line, and I'm just going to ignore the other points for right now. So the slope of this line, we go down a distance from 10 to 8 is down 2, so down 2, and then from 5 to 6, we went right 1. So my slope is y equals negative 2x. And then I actually don't know what this b value is yet. I need to do a little bit more calculation for that. So what we can do is we can use one of these points. If I use this point right here, that is 0.510. And I can say, well, that's my x and that's my y. And if I plug in, I'm going to do this over here. Y equals negative 2x plus b. If I plug in 10 and 5, then I can figure out what is my unknown y-intercept. So we get 10 equals negative 2 times 5 is negative 10 plus b. If I add 10 to both sides, I get 20 is b. So that means that my equation is here. And that is used to predict values. So if we wanted to predict how much you'll make in the 9th week, we could plug 9 in for x, and we would get negative 18 plus 20. And so we would make $2. Okay, that's it for today's lesson. Let me know if you have questions when you come to